Hi and welcome to Unit 4, Topic 3, Video 6, where we're looking at a more complex example of the Hungarian algorithm from a United Kingdom paper. So I'm going to take you through this example. It'll take a bit of time, and this is a harder example. Complex familiar, complex unfamiliar. So if you're not ready for this example yet, if you haven't tried some easier questions, definitely worth going back and trying some of the easier questions to make sure that you're ready for something like this. But if you're willing to go, the other thing you could do is pause the video and have a crack at the example now if you'd like to. Let's have a quick look though. We're raising money for charity. There's a lot of context here that we might not need all of straight away. There's 4 stages: cutting, stitching, filling and dressing to making a teddy bear, and a charity event is to make 20 teddy bears as quick as possible. There's 4 members of a team, A, B, C and D they're called in this case, and each of them's got an allocation on how many seconds it takes them to do each of the jobs. So for example, person A takes 66 seconds to cut, 101 seconds to stitch, 85 seconds to fill and 36 seconds to dress. Now, person 1 in this case, we probably don't want them stitching. We can see that person B and C are probably the better choices there, but alas, that's fine. Maybe that will be the appropriate allocation when we get there. So we just really can't second guess this. Part A says use the Hungarian algorithm, reducing rows first to obtain an allocation to minimise the time taken by the teams to produce 1 teddy bear. So the 20's out for part A. You must make your method clear and show the table after each iteration. Okay, so welcome to your nightmare. To this Hungarian algorithm question. I've already preset some tables. I don't want to spend a lot of time drawing in front of you. And here's the initial data. Person A, B, C, D, cutting, stitching, dressing and filling. And there's the time it takes for each person to do that. So we're going to follow that Hungarian algorithm process. Step 1, row reduction. Start with row A. The minimum is 36. Subtract from each. Gives me 30, 70... It's incorrect, so taking away 36 gives me 65. Taking away 36 from that, 79, 49, and then 0. Call that into your screen if I get one of these wrong. 66 minus 38 is 28. 98 minus 38 is nice and easy, that's just 60. 74 minus 38 is 36. And 0 again. And then 34 from these. 34 from 63 is 29, 34 from 97 is 63, 34 from 71 is 41, 37, and then 34 from 34 is 0. And then 35 from each of these, that's 32, 35 from 102 is 97, 67, 35 from 78 is 43, and 0. So there's our first one with the row reduction. Now we're going to shoot up here and we're going to do a column reduction. So we look at each column and reduce. So in the first column I'm reducing by that minimum value 28. And you can do this. You could circle each minimum value as you go. That can sometimes help out. So 28 from each of these gives me 2, 0, 1, 4. So what should happen is it should reduce down over these two quite quickly down to some nice low numbers, unless you've got some really erratic data. 60 is my lowest here. So I've got 5, 0, 3, 7. 36 is my lowest here, so I've got 13, 0, 1, and 7, and then I've got a whole bunch of zeros. So now I'm on step 3. Can I cover this in less than n equals 4? And the answer is yes, I can. So now I've got to go back to that next step of the process, find my minimum value, add to my double covered, subtract from my no covers and do nothing to my single covers. So I'm subtracting from 2 to give me 1, 4, 12, that stays the same. Same, add on to my double covered, subtract, 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 stays the same. Subtract, 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 stays the same. Can I cover this up in less than 4 lines? Well, in this case again, I can see that I can. So I'm back to step 4 and building through that adding and subtracting process again. My minimum is 1, so I'm going to subtract 1, subtract 1, subtract 1, leave the same as it's got 1 line over it. I'm going to leave the same, leave the same, leave the same, add 1. I'm going to leave the same, leave the same, leave the same, add 1. And I'm going to subtract 1, subtract 1, and leave the same. Can I cover this up in less than 4 lines? I'm going to go for the big bonus here. That covers up 3 of them. That covers up 2 more, and I can see here just through order of systematic approach that I just can't do it. So I can do that, but it's 4 lines. So that's the best I can do. So now I'm going to go to my matching. So over here I've got A, B, C, D, and then I've got C for cutting. So I might add a little bit to this detail for the C. S is alright, F is alright, and then D, R for dressing, just to not mix up the C and the D with the CU and the CDR. So now A is connected to C and D, or CU and DR. B is connected to CU, S and F, so CU, S and F. C is connected to CU and F, so CU and F. And D is connected to DR. So I can see straight away that D has to be DR. And I can see straight away that if D is DR, then that means this one's out, and A has to be CU, which means that this one's out and this one's out, which means that C has to be F and B has to be S. And I can go back to my original timings and add all these values together. So I'm going to do some circling. D is DR, or actually I'll do some starring because I've already done some circling here. A is CU, B is S, and F is C. So I get 35, 66, 90, no that's not, that's 71, and then that's 98. And when I add all those together, it's 11, 12, add that together I get 270, or 3 minutes and 30 seconds. So there's our answer to part A. I'm going to rub some of this out now, and we'll come back and have a look at the answer of part B and part C. Okay, now I've left this part, they're important parts for our next section. Would you believe it, I've actually accidentally answered part B. So this is our answer to part A, and this is our answer to part B here. Hopefully you'll do that and designate it a little bit neater than me in your exam. Part C though says, what's the minimum time taken to fill the order of 20 teddy bears, or in this competition, build 20 teddy bears? Now the issue is that we have to read into the context for this question, because the most common answer in this exam was 270 seconds times 20, which is actually incorrect. Instead, what we need to realise is that the answer comes from the fact that the first person to go is A, who does the cutting. So if A does the cutting, that takes 66 seconds. So this is for teddy bear 1, and teddy bear 1 is 66 plus 98 seconds for B. This is A, this is B, then plus C, then does 71 seconds, and then plus D takes 35 seconds. But once we're through the first 66 seconds, person A can start on teddy bear 2 before teddy bear 1's finished. Teddy bear 1 is further down the production line. So A now starts on teddy bear 2 as B finishes teddy bear 1 and does the stitching. Now of course A is going to finish cutting teddy bear 2 before B finishes stitching teddy bear 1, because B takes longer to stitch than A takes to cut. So 66 seconds, there's going to be a bit of an overlap. So this is where it gets a bit tricky, and we need to realise something important. A's time doesn't actually matter. A can cut again, and then have a 32-second rest, because B's not finished yet, and so B's not waiting on A. And C receives something from B, does the next job in 71 seconds, but then has to wait a further 27 seconds before B has produced the next thing. Okay, D on the other hand, 35 seconds, got to wait for C to finish, who's got to wait for B to finish. D's got heaps of overlap time. D's sitting around doing nothing for most of the time. It all hinges on B. So this is what happens. A starts the first one, B sits still for 66 seconds. Then B receives the first one to stitch, and B is now going constantly. A is feeding him more cutting, more stitching. So B now stitches up 20 of our teddy bears. Takes 98 seconds for each one. And then we've got C, who's doing F, which is the filling, only takes 71 seconds, which means that C's got this rest time. But once B finishes the last teddy bear, well, C has to fill the last teddy bear. So that's going to take 71. The rest of the time, the rest of C's job is absorbed into B's job. And then, of course, once C has filled the last teddy bear, D has to dress the last teddy bear, which takes 35. And so we have a minimum of 66 plus 20 times that, which is 1960, 2026, 2126, 2132, 2132 seconds, which is 35 minutes and 32 seconds. So that's our minimum time based on this allocation. We do have a minor problem with this question. And so this is a good answer, by the way. I just want to really stress that out. It's a really good answer. But the problem with this question is that everything hinges on B. B is 20 times more important than A, C or D, who get lots of rest time. If I go back to what I've got here, I can see that I've got C could do the stitching job, which is the longest job, quicker than B. So if C did all the stitching, that would be a 97 and would save us 20 seconds. Okay, so that's good. But that means that B then has to do the filling. And that's the obvious answer because this is now the next best in terms of filling time. That would take an extra 3 seconds. So this would now be 74, which is plus 3. But that's still overall because there's that one extra. There's still lag time for the other 19. It's only the last one where there's an extra bit of filling time. So we save 20 seconds, but gain 3 seconds, which means an overall saving of 17 seconds. So the real answer is actually 2115 seconds, which is 35 minutes and 15 seconds. But we have to be very careful to read the question because the question might say using this allocation from answer A, which is what the question did say. So this is actually the correct answer. It's not the minimum time, but it is the correct answer. So based on what the question said. It's about reading the question and interpreting. Classic, complex, unfamiliar. The math we've done here is nothing more than you've done before, but it is a question that requires you to do some pretty high level interpretation. Well, thanks for joining me. I hope that was interesting and that you learned something from it. All the best.